Lesson 1-3, solving equations with variables on each side. First off, to solve these types of equations, you're going to use addition or subtraction, property of equality, to get all variables on one side and the constant terms on the other. You can see in the box to the bottom right hand, here you can see that I'm adding and subtracting like terms on each side. So here I'm getting all my x's to the right hand side, so I'm just adding 2x to both sides. And here I'm subtracting 16 to get all my constants to the other side. Once you have all the terms on the proper side, you're going to combine like terms on each side. And what do I mean by like terms? Like terms means the term is a number and or letter that have the exact same letters and exponents if there's exponents involved, or they're just all constants, so you're going to combine them. So in this example, 3x and 2x are like terms. They both have an x, and so I'm just adding the coefficients. 3 plus 2 give us 5x. And over here, 16 and 1, they are both numbers. I'm subtracting the 2 to get your 15. From that point, you're just going to use order of operations. The last step here would just be divide by 5 because they are multiplying by 5. So first example, solve this equation with the variable on each side. So our variables are a's. You have to decide which side you want your a's on. It doesn't matter which side you put it on. You're still going to get the same answer in the end. It's just a matter, do you want to deal with negatives or positives? Most times I like to deal with positives. So I look at where my variables are, and I want to make sure that my coefficient in front of my variables remains positive. So here I have a 7a on the left-hand side and a 4a on the right-hand side. 7 is bigger, so I'm going to move everything to the left, all my a's to the left. So the opposite of adding 4a is subtracting 4a. And when I do that, I'm left with 5 plus 3a equaling a negative 13. Now, since I brought my a's to the left, I don't want anything else on the left besides a's. So I don't want this 5 here. So I'm going to subtract 5 on both sides, and I'm left with 3a equaling a negative 18. Now that I have my a's on one side and my constants on the other, now I can get the a by itself. The opposite of multiplying by 3 is dividing by 3. Whatever I do on one side, I do on the other. So I divide negative 18 and 3, and I'm left with negative 6. Now it does say check your solution. So check it just means put the number back in. So I have 5 plus 7 times negative 6 has to equal 4 times negative 6 minus 13. And I just solve each side. 7 times negative 6 is negative 42. Negative 42 plus 5 would give us a negative 38. Or not negative 38, negative 37. On the other side, I have 4 times negative 6 is negative 24. Negative 24 minus 13 gives us a negative 37. You can see that negative 37 does equal negative 37. So my final solution is x equaling negative 6. Next, solve for c here. Need to get all my c's to one side. Now here I have a negative 13c and a positive 4c. If I want to remain with positive c's, I don't want this negative 13 in here. So I'm going to move my c's to the right. I'm going to add 13c to both sides. And now I'm left with 5 equaling 4c plus 13c is 17c plus 39. Now to get all my c's to the right, everything else has to go to the left, so I need to subtract 39. When I subtract, I end up with negative 34 equaling 17c. The opposite of multiplying by 17 is divide by 17. And and I'm left with C equaling a negative 2. To check my solution, I put negative 2 in for C. So now I have 5 minus 13 times negative 2. This has to equal 4 times negative 2 plus 39. 5 plus negative 13 minus times the negative 2 is a positive 26, which will give us a total of 31. On this side, I got negative 8 plus 39, which will give us a positive 31. So my answer is C equaling 2. Now let's just say I didn't want to bring my C's to the right. I wanted to keep it to the left. So I would have 5 minus 13C equaling 4C plus 39. To prove that I would still get the same answer, if I subtract 4C on both sides, I end up with 5 minus 17C equaling 39. Subtract 5 on both sides. Now I have negative 17C equaling a positive 34. Divide by negative 17. C would still equal a negative 2. Moving on to our next question. This is a two-part question here. It says the results of the 2020 Nathan's hot dog eating contest is shown. So in the picture here, we have two people. We have Joey Chestnut and we got Mickey Sudo. And you can see how many hot dogs they ate, including the bun, in 10 minutes. So what are we going to do with this? So suppose the men's and women's winners, Joey and Mickey, decide to compete against each other. To make the competition more interesting, Joey will not start until Mickey has eaten 15 hot dogs. Assume that Joey and Mickey eat at a constant rate, which just means their pace stays the same throughout the competition. Based on the number of hot dogs eaten in 10 minutes by Joey and Mickey, how many minutes after Joey starts eating will they have eaten the same number of hot dogs? To start off, we need to know that Joey has to equal Mickey's number. So Joey's number is 75 total hot dogs, but that's in 10 minutes. We want to find out, looking at their rate. So if Joey ate 75 in 10 minutes, that is 7.5 M. So let me use a different, I'm going to do 7.5 T for, actually no, I'll use M for minutes. 7.5 per minute Joey would eat, and Mickey would be 48.5 hot dogs, but in 10 minutes that would be 4.85 a minute. But we need to make sure that they equal the same amount. It says that Joey will not start until Mickey has eaten 15 hot dogs. So if he goes at a 7.5 rate, but he cannot start until after Mickey has eaten 15, I need to add 15 hot dogs to Mickey's side, and then they would be equal. But right now it says how many minutes after Joey starts will they have eaten the same number. So now I need to solve for M. So I have my equations. I need to get all my M's to one side. Since 15 is on the right-hand side and I don't have any constants on the left-hand side, I'm going to subtract 4.85 M on both sides. And now I'm left with 7.5 minus 4.85. That gives me 2.65 M equaling 15. Now the opposite of multiplying by 2.65 is divide by 2.65. I'm going to do that on both sides. And I have 15 divided by 2.65. And you're going to get a decimal. The decimal is going to be 5.660377358. So we're going to estimate this. So we're going to say roughly 5.66 minutes. So I just went to the nearest 100. So after about 5.66 minutes, after Joey starts, will they have the same amount of hot dogs to eat? Next, Nolan and Victor were two of the top scoring freshman players in a college basketball conference last season. The table shows how many points Nolan and Victor scored and how many games they played last season. So Nolan played 30 games and scored 750 points. Victor played in 34 games and scored 782 points. The points in Victor they scored will be combined with their points from last season to give their total career points. This season, Nolan is hoping to catch up to Victor and have the same number of career points. Assume that Nolan and Victor played every game and scored at the same constantly as last season. So how are we going to do this? It says part A, based on each player's average scoring rate. So we need to first find their scoring rate. It says write an equation that represents the number of games it will take Nolan to accumulate the same number of career points as Victor. So in the end, I want N to equal V, Nolan to equal Victor. The first thing we need to do is find each of their average points per game. So I take for Nolan 750 and I divide by 30. I did 0 on 10 on top and bottom, and I'm left with 75 divided by 3, which will give us 25. So Nolan scores 25 points per game. And Victor would be 782 points for 34 games. If I do 782 divided by 34, I'm left with 23 points per game. Okay, I need Nolan to equal Victor. So Nolan, his was 25 points per game, and I'm going to use G for games. Actually, let's do 25 P because we're going to need to know how many more points. Any equation that represents the number of games it will take. So I'll use G. 25 points per game, plus he scored 750 before, equals Victor's points per game, which was 23 G, and they started off with 782 points. So now we have our equation. Now we can use that to now solve for how many games this season will Nolan and Victor have scored the same number of career points. So to do this, I'm going to get my G's to one side. I'm going to subtract 23G. And if I'm bringing the G's to the left, I don't want the 750 here, so I'm going to subtract 750 on both sides. And that gives us 2G equaling 782 minus 750, which will give us 32. Get G by itself, I divide by 2. The number of games where they will score the same number of points in the end would be 16 games. Next example says Marley and Bennett are training to run a marathon. In the first week of training, Marley runs 11 miles and Bennett runs 14 miles. Each week, Marley increases her weekly total by 2 miles and Bennett increases his weekly total by 1.5 miles. Write and solve an equation to find how many weeks after the first week of training Marley and Bennett will be running the same number of miles. So just like our last one, we need to make Marley equaling Bennett. Marley's starts with 11 miles, plus they increase by 2 miles per week. So I'm going to put 2W for week. Bennett starts with 14 miles, and he increases his weekly mileage by 1.5 per week. Now we solve for W. Since 2w is bigger than 1.5w, I'm going to subtract 1.5w on both sides. So bring my w's to the left. That means I'm going to subtract 11 on both sides, bring my constants to the right. And I'm left with 0.5w equaling 3. Yeah, so multiplying by 0.5 is divide by 0.5. And the number of weeks it would take. So 3 divided by 0.5 would give us 6. So after 6 weeks, Marley and Bennett would have the same number of miles. Next part of our lesson, using the distributive property. Some equations contain grouping symbols. Grouping symbols represents parentheses, or you might see brackets, and you might see fraction bars involved with it. For any of those, that would be included with P for PEMDAS, or parentheses or brackets. We want to get rid of all of those before we do anything else. So here are some steps you can follow. So simplify the expressions on each side. Remove any grouping symbols and then use the distributive property as needed. You use the distributive property also to just get rid of parentheses, to knock them down. Step 2, use addition and or subtraction properties of equality to get the variable terms on one side of the equation and the constant terms on the other. And then you can simplify from there. And your last step is always going to be multiplication or division. So an example here. Here I have an equation with variables on both sides, and I got parentheses in here. First step I want to do is get rid of my parentheses. To do that, I'm going to distribute. So 7 times n is 7n. 7 times -1 is -7. I don't have any more parentheses on that side, so let's get rid of it on the right-hand side. -2 times 3 is -6. -2 times 5, or -2 times n is -2n. Now that I don't have my parentheses involved anymore, I can now get my n's to one side. I'm going to add 2n to both sides to get all my n's to the left. And I'm left with 9n minus 7 equaling -6. I don't want this -7 here, so I need a constant terms to be on the other side. So I'm going to add 7 to both sides. And I'm left with 9n equaling a +1. And my final step to get n by itself, the opposite of multiplying by 9 is divide by 9. Left with n equaling 1/9. Question, the second example, or question example 3. Again, I have parentheses, so I'm going to distribute. So I have 7n minus 14 plus 8 equaling, distribute 3 here. And I got 3n minus 12 minus 2. Now you'll notice that I didn't distribute to the third number. And you might wonder why I didn't distribute to the third number, because it's not in the parentheses. I'm only multiplying 7 times n minus 2, and then the 3 by the n minus 4. Now that I got rid of my parentheses, I need to combine like terms on each side. So I have 7n, -14 plus 8 is a -6. Here, 3n, -12 minus 2 is a -14. Now to get all my n's to one side, I'm going to bring my n's to the left. So I'm going to subtract 3n. And to save space, I don't want this -6 here, so I'm going to add 6 to both sides. And I'm left with 4n equaling a -8. To get n by itself, I divide by 4 on both sides, and I'm left with n equaling a -2. Again, you can check your work by just putting -2 in for n and making sure that both sides are equal. Next one, 7 equal and -11 plus 3 times b plus 5 in parentheses. To break down the parentheses, I distribute. And I'm left with 7 equaling -11 plus 3b plus 15. Need to combine like terms, so I can do -11 plus 15, which is 4, plus 3b. Since the b is already on one side, let's get rid of this 4 by subtracting 4. and I'm left with 3 equaling 3b. To get b by itself, I divide by 3. B would have to equal 1. The more you do these types of problems, the easier it becomes. Example 4, now here we have a fraction bar involved. We need to get rid of all fractions. So to do that, multiply each side by the denominator. So I'm going to multiply by 4 here. 4 divided by 4 is 1 times 12y plus 16 is 12y plus 16. Whatever I do on one side, I do on the other. 4 times 5y equals 20y. Get my y's to one side, so I'm going to subtract 12y. And I'm left with 8y equaling 16. Get y by itself, I divide by 8. Y would equal 2. Next example, example 4. Again, I got parentheses and fractions. So the easiest way right now, like for me, what I would do is get rid of my fraction first. So I'm going to multiply by 2 on both sides, get rid of my 2 here. And then whatever I do on one side, I have to do on the other. But you notice I put parentheses here because I have to multiply 2 by everything on the right-hand side. And I also have parentheses here, so I'm going to distribute, and I get 9n minus 6 equaling 6n plus 2. Now I'm left with a similar problem like I had before. I'm going to subtract 6n to get my n's to the left, and then add 6 to get my constants to the right. Now I'm left with 3n equaling 8 to get n by itself. Actually, here this is not positive 2. This would be 6. So that would give us 12. Let's do that one over here. So the 6 n's cancel off, and I'm left with 12. So 3n equaling 12. Now I can divide by 3, and my n would equal 4. So you can see it's very easy to make a mistake if you skip a step. And then you'll wonder because like your answer doesn't seem like it'll make sense. Usually if you have a really weird answer, such as a odd fraction or like a really long decimal, that is usually a clue that you probably did something wrong in these types of equations. Most times it's going to give you an integer. Next one, I have fractions involved, so I'm going to get rid of my denominator by multiplying by 5 on both sides, and I'm left with 6x minus 9 equaling 15x. Get my x's to one side, I'm going to subtract 6x. I'm left with negative 9 equaling 9x. Divide everything by 9. X would equal by negative 1. Example 5 says write an equation with grouping symbols. We're going to find the value of x so that the figures have the same area. So we want to make the areas equal to each other. So to find area of a rectangle, I have length times width, and find area of a triangle, base times height divided by 2. So on this side, I have 5 times x plus 4. That area has to equal the base is 12 times the height, which is 2x minus 6. Divide that by 2. Now I can simplify this. 12 divided by 2 is actually 6. So if I rewrite this, I would have 5 times x plus 4 equaling 6 times 2x minus 6. Now to get rid of my parentheses, I'm going to distribute. So I have 5x plus 20 equals 12x minus 36. To get x by itself, get all my x's to one side. So I'm going to subtract 5x here. And I'm going to add 36 to both sides. And I'm left with 56 equaling 7x. To get x by itself, I divide by 7. 56 divided by 7 would give us 8. X would equal 8. And if I check my work, 8 plus 4 is 12. 12 times 5 is 60. Over here, if I put 8 here, 2 times 8 is 16. 16 minus 6 is 10. So if I do base times heights, so base is 12, divide that by 2, I'm now left with 120 divided by 2, which was 60. Next one, find the value of x so that the figures have the same area. So we want the areas to equal each other. This would be 10x equaling, down here you have 3 plus x, so this would be 6 times 3 plus x. Distributes, now I have 10x equaling 18 plus 6x. To get my x's to one side, I'm going to subtract 6x, and I'm left with 4x equaling 18. To get x by itself, I divide by 4, and I'm left with x equaling, I can divide this by 2 halves, which will give us 9 halves, 4.5. Next one, write an equation with grouping symbols. Another one here, so we're just making sure that each shape area equals each other. So base times height divided by, actually no, this one is in a perimeter. So the perimeters have to equal. So I'm going to add up all the sides. So 1x plus 1x is 2x. 6 plus 4 is 10. So I'm only adding like terms. So what this is really saying is x plus 6 plus 4. If I add like terms, you get the 2x plus 10. This side, I add up all the sides. This is a square. This is x plus 1, and this is x plus 1. So I got 1, 2, 3, 4 x's. So 4x plus 1 plus 1 plus 1 plus 1 is 4. Get all my x's to one side. I'm going to subtract 2x on both sides and then subtract 4. I'm left with 2x equaling 6 divided by 2. X would have to equal 3. And our last part for today is identities and equations with no solutions. So you have one solution, no solution, or identity, which means it's many solutions. An equation has one solution if exactly one value of the variable makes the equation true. An equation has no solutions if there is no value of the variable that makes the equation true. This means I can put any number in there and it won't make sense. And the last one says an identity is an equation that is true for all values of its variables. So this one means I can put any number in for the variable and it will always be true. So how do we do this? So the first one is with no solution. So I need to get rid of my parentheses, so I get distributes, and I get 6y minus 30 equaling 20 plus 6y. Get my y's to one side. I'm going to subtract 6y. And if you notice, I end up with negative 30 equaling 20. When the variables and the coefficients are identical on each side, that is a clear sign that this is going to be a no solution as long as these other numbers remaining aren't the same. Negative 30 does not equal negative 20. Therefore, this is no solution. Now, let's just say you went further. Let's just say you did go further with this one and you added 30 to both sides. Now you're left with 0 equaling 50. 0 still does not equal 50. Therefore, no solution. Next, you get all the c's to one side, so I'm going to subtract 1.3c, and I'm left with 2c equaling 2.8. To get c by itself, I divide by 2, and I'm left with c equaling 1.4. Since I have one solution where c equals a number, there is one solution. Over here, distributes, so I have 5h plus 7 equaling 5h minus 10 plus 7, or plus 3. Combine like terms. I got 5h minus 7 over here. If I subtract 5h on both sides, I'm now left with 7 equaling negative 7. Well, 7 cannot equal negative 7, therefore it's no solution here. Next, distributes. So I got 5 plus 2n plus 2 equals 2n plus 9. Combine like terms here, I get 7 plus 2n equaling 2n plus 9. You'll notice that the coefficients and the variables are the same. So when you bring them together, what I have left on each side are not the same. If I subtract 2n, I now left with 7 equaling 9. That never happens. So this is no solution. And letter D here, I distribute. So I have 6a plus 24 equaling negative 18. You notice I only have variable on one side, and usually if you find the variable only on one side, you're going to have one solution. So if I subtract 24, I now have 6a equaling a negative 42. Divided by 6, a is going to equal a negative 7. So I have one exact solution. Next, solve identity, which means you have many solutions. If I distribute here to get rid of my parentheses, I'm left with 7x plus 5x minus 5 equals 12x minus 5. If I combine like terms here, I'm now left with 12x minus 5 equaling 12x minus 5. Now when both sides of the equal sign are identical, everything's exactly the same, that means this is many solutions. Or you can say this is an identity. Now if you were to subtract 12x on both sides and add 5 to both sides, you would have 0 equaling 0. As long as a number equals itself, it's an identity. Next, solve these. So here, distributes. So right now I got 8g plus 48 equaling, distribute here, 5g plus 3g is 8g, 3 times 16 is 48. You'll notice that they are both the same, so this is an identity. Next one, 5x plus 5, distribute here. So I got 5x plus 5 over here equaling 15x plus minus 10x is 5x, negative 12, so minus 12. 5x's are the same, but these other numbers are not. So that means this is no solution. This next one, if I subtract 3w on both sides, I now have 2 equaling 4w, divide by 2, or divide by 4, I mean, w equaling 1/2, which would be one solution. And our last one here, distributes, I get 6b minus 3 minus 7, so I have 6b minus 10. This equals 6b minus 10. Since they're the same on both sides, this is identity, or you can say many solutions. Some more with identities. So if I distribute here, I have ax plus 12 equaling 2ax plus 12 minus ax. I have ax plus 12 equaling 2ax minus ax is 1ax plus 12, both the same, so this is an identity. Now this one is just, we just have to show that it is the same on both sides. That is our only questions we have left for this type of lesson. So that is all we have with solving equations with variables on